Hi Bellum. Hi Nancy. How's it going, guys? Hey Betty. It's been a while, I think, for both me and everyone here. How's it going? How's it hanging? How are things? She's telling you about it. It's getting better now? That's good to hear, yeah. That's nice. So many issues since I last saw you. Well, it's great that you're doing better. It's great that you're doing better, Betty. Good to hear it. Bellum, have you been here every day since since like last week? Arm injury from who knows what, back rib injury from lifting a car jack when I was angry, car breaking down, flaky mechanics. Oh no. that sounds hard to deal with. I'm saying yeah. Sorry about that, Bellum. I just got really busy. But now I'm back. I have to finish this by. I have to finish this thing by Friday, so I'll be here definitely. This thing needs to be at least 7.5, I think. I like that Starstream as a milestone. I also agree. I realistically just have it there so that every time I make one of these charts, I don't have to copy paste the check mark, but it makes my life slightly easier when I complete a task. But yeah. I mean, at this point, I count it as a milestone. That made you feel good about accomplishing something. That too. That too. Uh, so, I need to like. Theoretically, I can finish all this by Friday. That's my goal, anyways. Like all I have to do is I made some redesigns to the chamber yesterday. In like around 1 hour, so that this thing is actually printable because this is really badly catted. I'm gonna be honest here. And so that was that. This entire thing is due on Friday. So, no pressure there. Yes, I started the stream. Let's go. That's me internally. Who's the responsible party? No pressure, buddy. No pressure. You got this. Oh, thank you. Thank you, Bella. And thank you, Betty. If you think you can, you can. I'm still waiting on a bunch of things, actually. I can't deliver the Blinky Loaner kits until my stickers are here. It didn't say which Friday. It's this Friday. It's 3 days from now. So I'm printing one of these cages off my printer. What am I doing? Hold on. I'm printing one of these cages off my printer right now on Belty. You'll do the heavy lifting for the most part. This piece is mainly just to, well, let me explain what I'm doing first. So yesterday I went ahead and made this thing printable, which means redesigning the top part. I split the battery chamber into different components, like this top piece here, this bottom piece here, this like little slaughter piece in the middle. I made holes for it and everything. And also this little back piece was like the hardest thing to print ever because of how it was designed. I don't know what happened. I tried to print it twice, and it, just destroyed itself in Belty. Here's the official thing: whenever someone asks when X will be done, you answer a week from Friday. That's official from people with millions of dollars. Seriously, you don't say which Friday though. I mean, I have a technical meeting with the people I'm supposed to turn this into this Friday, so I really hope I have it done this Friday. Okay. And then, so I have this piece, which looks pretty funny. This piece is supposed to be a wire holder for the electronics that are eventually going to come from the other side. Because this is supposed to hold a battery either while it's in the ground or if it's in the air. It's got to be slightly versatile. So this piece is going to be pretty important. It locks onto the rest of the diagram right here. The rest of the model. That body there. This is going to be, there's 43 bodies already. Wire holder. You put it as a component. Let me just make another component here. Just call this external. Alright, so the wire holders are going to be, my organization in this file is actually kind of okay, considering some of my previous projects in the past. Is there an easy way to select like the middle of this thing? Shift the key. Control. Control. There you go. One dedicated wire holder coming right up. and then I just duplicate this on the other side. Alright, so I'm going to go ahead and rotate this 180 degrees. Bring it all the way out here. Whoa! Okay. Just go ahead and joint it. Control. Oops. Joint. Okay. Alright, that was the easy part. Let me go ahead and get my constraint arms. I'm going to drag it into external as well. Solenoid arm. Same for this one. I can go ahead and delete this component. Never mind. Just put it as like underscore. Okay. So these solenoid arms are going to go in, attach themselves to the battery. All as well. Okay, now I have to actually make the actual solenoid piece. Are they technical? I think they are. They're technical as they can be. I love threads, there's nothing sexier except for maybe cams. Ooh, cams. Perhaps. Alright. Like, what's my next thing on my milestones here? Redesign solenoid support, and then test the solenoid support, and then test the slotting mechanism. Oh, I should show you guys the slotting mechanism. Oh, this thing is extremely questionable at best. So, printed a bunch of these battery carriages, right? And then I printed this thing, which is like really fragile. It's the slotter that's supposed to go at the end of this battery chamber. And so, if you take one of these batteries and you slot them into, pretend there's like a big battery chamber here, and you slot it into them like this, right? It goes all the way in, and it's very flush with the battery chamber. Like look, this is a nice fit. It's very, Why did you make it so fragile? It's a prototype, Betty. Like, you could probably break off these, like, little nubs here and nubs here if you gave it like no, nice. This is the wrong part. I'm gonna print this out of resin eventually, so it's not as fragile, but like it works. This is the end of it. This thing has screw holes on like all four sides of it. Eventually gonna coat it with Bellum's conductive glue paint thing, and it's going to slide right in. So now the difficult part is just getting the contacts to work. I think it's to the point where it's a good contact. I just need to test it. But like it goes right in. It's a very nice fit. I'm gonna like count my count the seconds it'll take before one of these gets stuck inside of the battery chamber. But it works. Anyways, what does it do? Well, this is supposed to be a compartment used for making the identification of data from batteries easier to do for multiple applications. For our case, it's for using it for drones. So what we want to do is have drones go on like long endurance flights, because that's something that's really popular these days apparently. And so in order to do that, the drone may need to land on the ground to perform repairs, to swap out batteries, etc., right? And so when it swaps out the batteries, which is in my department what I'm like doing, it'll need to be removed from the drone using a robotic arm, and then it needs to be placed in a compartment that can identify its like voltage, charge, lifespan, whatever, right? And so this is going to be the compartment. The battery will go into here, which the battery is going to be this thing. So the battery slides in. It locks itself into the back part, which is the slaughter. There's a bunch of electronics here that go ahead and map the XT60 and JSD connectors with two main power and data lines. And basically these two arms come in here and lock into place. So they lock into the battery's internal parts, preventing it from moving using a solenoid. And that's what I'm supposed to be designing right now, is the solenoid that clamps into this thing. And then this is supposed to be holding the wire that goes from the solenoid into the electronic compartment that acts as kind of like the control for whether to release or hold the battery in place. Even better, in-flight hot swap battery exchange. I think one of the teams, at least in Cal Poly, not in my project, but they are trying to attempt to do that. So I think it's pretty interesting to see what they're going to do. Hot swapping power in the air is hard, though. But yeah, that's what my job is, basically. So, in reality, I've already designed like one of these pieces, which is this thing here. Specialized battery drone. Yeah, pretty much. Make them work like flies mating. Those are some pretty large flies, Betty. So anyways, back when I actually made this little part, I went ahead and measured how long this was supposed to be. Apparently 45 millimeters, and I'm not sure if this is like too far in or not, which is why like this part has to be extensively tested as part of like the solenoid attachment, really. And so I have this attached on 4 corners, but depending on its applications, it may have to. This may double as kind of like the attachment to the drone. But in this case, I only wanted to contain a solenoid that locks the solenoid in the center and allows it for it to be a pushing arm. So I'm using like these solenoids here. These are basic, your basic 12 volts, 5 volt solenoid that pushes and pulls. Theoretically, this arm is in the center, and theoretically, all I need to do is make sure it prints this at the correct size so that I can just lock it into place. The idea is that I can just like push it into the position, and maybe like it'll be a press fit, or it can be like a just like I can hot glue it in if possible. But my original design of having 2 holes in the bottom is really a bad idea, because these holes are not standardized. They're like randomly placed. So I created this little test platform and realized that if I went ahead and screwed this in. Question, teacher, why a robotic arm to deal with the battery? Good question. The robotic arm is not just for the battery. Because this is a whole ground station that the drone is landing on, the robotic arm is supposed to do other like tasks, like repair on the drone, maybe like swapping out a compartment or two. I think just mainly the repair part of it, because if it was just a battery, there could be like a rotating chamber for it. The robotic arm is supposed to be multi-purpose, so not just for replacing the battery, but also replacing drone parts if needed, swapping out like, I don't know, a transmitter for another transmitter, something like that. Robotic arms are not my department, so I don't know clearly what's going on with them. But in general, that's why. So it's not supposed to be a hands-off drone pit crew. It's supposed to be a hands-off drone pit crew, or technically the robotic arm is the hands. It's supposed to be an autonomous ground station, or a ground station in which doesn't require a human to be there. So if a human can access this ground station and repair the drone, even if they're like miles and miles away, then it's a success for this project. Because theoretically, if you put it in like a could be revolutionary if it works. Apparently so. Apparently we get sponsored a lot for this. Like, let's say you put it in like the Nevada desert without like anyone around, and the only way of contacting this station, this like drone station, is via like some long distance RF technology, right? Radio frequency or like something like that. If there's no Wi-Fi, and then you can like do things like pass camera data through that signal, or go ahead and measure other points of data, or just repair the drone autonomously, depending on if drones come to the ground station. My job is just to make sure that batteries can come in and out of this area. So, kind of like a drone pit stop for batteries. Yeah. Laura, I don't get that reference. Do you get the fuel guy in racing? Sound like that boat robot. He comes out with a big jug and funnel. I see. So the idea here is to create an offset plane first. Create like 5 millimeters away. The idea is that I'm going to use these 4 like central junction points in order to create a an attachment for the solenoid itself, and then find a way to clamp it in place. So projecting this and projecting this, and then just creating a big old square. So theoretically, the central point of all this is going to be in here. With, let's say, the screws. Well, the screws need at least 7.5 millimeters, or else they're not going to screw in correctly. Let's go ahead and make that then. Hi, Kandarsa. LoRa actually is wireless modulation that enables communication with very low power consumption. LoRaWAN refers to a network protocol with LoRa chips for communication. I see. I might have to look into that then, if we're actually going to put this out for a field test. We were talking about using distance for the application of this project. Why is the bottom 8 millimeters? What happened to like 7.5? Alright, sure. Okay. So theoretically, right? I'm gonna give this a good base first, and I'm gonna start cutting things out. Don't want a repeat of the battery chamber. I'll give it a good base of like 5mm, just so that if I screw something in, it's gonna be very nice and sketch 88, huh? If I screw something in, it's gonna be very nice and secure. And I'm gonna go ahead and street this out some more. In sparsely populated areas up to 55 kilometers between transmitter and receiver, road trips are a little pricey, and the city range is reduced to a few kilometers because of buildings, but it's got good penetration. Underground sensors can also be reached. 55 kilometers is created when Bluetooth is 100 meters. Bluetooth has no penetration. There is public LoRaWAN thing, but my area has no bridges or demand. Interesting. I gotta do some more research onto this later on. Alright, so I'm gonna go ahead and extrude everything here in the middle. Maybe not like that. Congrats, Condarsa. Good job. Okay. I just have to decide on how big to extrude this thing, because I know it is supposed to be... Okay. I think I have an idea. So I'm going to extrude this, I think this distance was like 45 millimeters back. I think. But it's not going to be like this huge monstrosity or whatever this thing is. Looks like a funny shape. So this thing was... Like, this measurement has to be really precise. It's 45 millimeters, okay. From front to back. Okay. Cursed cat. Make it huge. Oh, Bellum's here. Bellum's somewhere. He was here, but I think I scared him away, I think. I love some cursed cat. Okay. I think I can go ahead and get rid of the middle part. It's really close to the back. I think I should extrude it 50 instead, just so I can get the measurement exactly correct. Okay, you know what? I'm gonna make a new one. On my list of like oddly shaped shapes, this is like on my list of shapes that are oddly shaped. This is definitely a shape and a half. What am I doing? What was my plan going into this? Hold on. I think I'm getting confused. What was my plan? Did I even have a plan? Right, it was like this. That was the screw holes. I think it needs a little bit of this action here. Missing 2 lines. Okay, and then I probably can go ahead and execute this portion of it now. Maybe. Sure. Sure, I'll go with that. Okay. This being like for this supposing to be a robust solenoid holder, it's not looking. My chances of making one are not great at the moment. What do I have? I have a way to attach this thing to the side of the chamber. I have holes. I can make holes, I think. I can make holes. Yes. Okay, let's see if I can memorize the M3 screw orientation. What's my M3 screw settings here? Not selected. What? Okay, M3 screw settings. It's going to be a counterbore, simple, flat screw. It's going to go 5 millimeters deep. Top is 6. Side is 2, and then this is 3.5. Okay, screw complete. Well, that's interesting. Okay, hold on. Let me get this straight first. This solenoid is not going to directly fit in the back, right? There's going to be some sort of tolerance to prevent this from happening, right? Maybe. What's the size of this thing? It is. Tolerance has to be pretty exact here. I'm gonna go 23 millimeters. Okay, so find the center first. Okay, and then from the center, horizontally I have 23 millimeters. Don't know if that's even the right number. I don't know the PLA to aluminum tolerances. Hold on, I have to reach out. I am always here. Is there a right-click option to make fragile? Is it my iris? I think trapezoidal. Uh, totally doesn't look square. All right. Thanks for being here, Betty. It was great seeing you again. I'll catch you next time when you decide to visit the channel. See you then. Funny comments though. So it's 23 horizontally. I mean vertically. And then horizontally it's going to be... I think I'm going to eventually have to like hot glue this into place. 26. Because... yeah, eventually I'm going to have to hot glue this into place instead of screwing it together. There's going to be so much force being outputted onto this thing. Good old hot glue. Yeah, hopefully I'll hop and see you more often. It's great having you here, Betty. We'll see you the next time you come here then. But yeah, good old hot glue. Yeah, hot glue solves problems. Yeah, I'm legitimately thinking of just doing this. No, not 45. What? Not 45. Not all the way. It'd be like half the way. How long is this thing, anyways? Like, if I put this in 25. Okay. So, like, to enclose this entire thing, I have to extrude at 25. And then theoretically, the entire solenoid is able to fit in the middle. Let me just like blow a big hole in the back. Make a large circle. This is gonna be for the back area, the wires and stuff. So the back plunger part is gonna be, say 7.5. I'll be generous. And then I need like a bottom hemisphere thingy for the wire. Blink. Okay. So theoretically that should be able to hold the solenoid together. Maybe. Now I just need to make it so that it doesn't look like hot garbage. Because right now it does look like hot garbage. This is going to take years to print. Like, although I think it works, I don't think my printer is going to like making this thing. So, I'm going to put the solenoid in. And then maybe I make a solenoid cover? I don't even know if that's a thing. Yeah, take care, Betty. Maybe I make something to hold the solenoid in place rather than extruding it out. So is this thing really 25 millimeters? 25 is like the bare minimum. I think it's more or less like 26. Maybe 26. 26. I know the tolerances for aluminum on PLA is like a little bit different than PLA on PLA. But I don't know if it's like a millimeter difference. I think it is. It's wild. So the solenoid goes in the middle here. Why are these two separate bodies? What? Okay, now it's not anymore. Okay. So what I'm gonna do is first I'm gonna go ahead and start holing out this area. think these side panels are fully unnecessary. I don't know why I made this in the first place. This is like extremely unnecessary. But, okay. I spoke too soon. That's gonna leave a mark. They are only slightly unnecessary. I changed my mind. They are only slightly unnecessary. Alright, they are unnecessary up to that mark, which is supposed to be 30 millimeters. You know what? Redo. Theoretically, if I extrude this up like 25. Oh, and now it looks even weirder. Oh, congratulations, me. I have made a solenoid cake. If I put in my X-ray vision, you can see it overlaps here. It's not completely out of hand. Completely. Okay, I wonder what other things I can take apart. Okay, so if I want to plane at an angle, I'm going to create a plane at an angle so that I can mirror this eventually. Like 45 degrees here. Nah. It has to be 45 degrees in the center, which means on the central axis through this thing. And then I'm going to need a plane through this thing. A 45-degree angle and a negative 45-degree angle. Great, now I can mirror things because this is symmetrical. Okay, so what I'm going to do is I'm going to start holing this out. My printer is going to absolutely hate me for this, but I don't care. So I'm going to go ahead and project this plane. And all I'm going to do is do a little offset action here. Like 3. Like 4. 5. Maybe like 2 to 5. Nah, 3 was better. 0.5 was better. Yeah, I don't think my printer's gonna like printing this piece out. I'm gonna be honest here. It's a fairly large rectangle. Okay. I guess I'll do this. Something like this would work. Yeah. It's too close to the edge, though. The ratio's off. Okay, that's slightly better. Alright, I just mirror this thing. Cool. And then I just mirror this thing again. Double cool. Okay, first part's done. Taking that big chunk out should hopefully help with the printing process. Okay, I wonder what's the gap in that. 5.75. That's enough for an M2.5 screw, I think. So if I put a screw in that to hold the solenoid together, that would work. Okay, I'm gonna leave that back portion alone. I'm gonna start filleting things. Fillets. So many edges to fillets. I don't think I did this correctly. Oh, hold on. I haven't streamed in so long, I just completely ignored chat for like 10 minutes, and I see that I have like a lot of exercise now, so great. Hi, Bellum. I was wondering, it's been since a while since Chris did some exercise. We not wanting to waste away, and I've only supposed to spend. Uh-oh. Save my work. Okay, let me do my save my work first, so I can save this abomination of a solenoid structure. And then Bobby redeemed do 3 sit-ups. Why would he have the point rewards if he did not want to do the exercise? Do your sit-up. He's just ignoring chat. I was ignoring. Well, I kind of was ignoring. Not on purpose! It's been so long since I streamed. I completely forgot that I had to look at chat. Alright, focus fully. Alright, I'm gonna do my sit-ups. Please hold. Oh, by the way, I didn't do an unboxing on the stream, but like, just want to show you guys this. I finally got my parts from JLC PCB, and they didn't send me a real resistors, but they sent me a box of about 5,000 resistors. And these are all resistors. There's so many resistors here. It's unbelievable. I have a reel for you. Oh yeah, Prinars, I still need to like trade with you. Still need to get that stuff. Also, their parts are really high quality compared to the ones I bought from Amazon. Like these are the dial potentiometers that I got. They're like all nicely put in these like rail thingies, and they're not all clumped together in a ESD bag. They're really high quality parts. I mean, I did pay like $300 for shipping for them, but still. Like, they're quality parts. I will save them for later. Anyway, sit-ups. Right. Okay. 3 sit-ups? Oh, hi, actually, Crazy. I don't know what you're saying, but I see you there. I hope my, I also need to vacuum my floor, because I'm starting to get, like, bug bites on my legs again. That's not fun. Alright, 3 sit-ups. Here we go. I just felt my back, like, snap in half by lying down. I've been sitting on at my desk for the entire day. Here we go. 1, 2, 3. Oh, I'm very out of shape. Yoshi eats cookies doing 3 push-ups? Oh no, that's even worse. That's even worse. I real for each of these. I just have address was going to just use the one from the box you sent me. I remember he used these steps with his legs flat. Yes, I did. Amazon, what happened to AliExpress? No, that was from JLC PCB. So like from the actual PCB manufacturing company themselves, they sent me a box. Moving him in the world. I can't send the box because my sticker manufacturer still hasn't given me the stickers for the box itself. So I've been waiting for those stickers for like a week. I mean, my sticker manufacturer is a high school, so I can't blame them very much. Yeah. You can just use the address on the box I sent you because I have your address. I did not keep it. It's okay. I'll send it to you eventually. Same for Bellum. And wherever Positron is, I also have a kit for him. But things have been going along here. Niacy's been doing great work sorting them out for me. Anyways, 3 push-ups. Now, before I do these push-ups, let me just preface the fact that I cannot do push-ups. And I will try my best, but it'll be a futile effort. So here we go. 3 push-ups. 3 quote-unquote push-ups. Alright. 1, 2, 3. Oh, my arms are in pain. That That was not good form. That was not good form. Obtuse angles. This can make for a good geometry lesson right about now. If Vellum clipped it, then it's in the channel's history for forever. My inability to do exercise is forever materialized in the form of bad form. You know what? Because of how this is locked onto the chamber, I'm going to completely remove these sides. It's gonna look weird. I know. But like from this angle, you can see everything that's happening, and I think that's what matters more. So then, from this point, I can just go ahead and fillet the rest. I think I'm going to apply a heavy chamfer on the top instead of fillet. Now you see, want to tell the stream how I've been making you sort all of my electronic components? I've been putting NIAC to work. Episode number 2 of my questionable designs. I'm gonna be honest here. These designs are questionable. Look at all those curves, though. Line on the top, bottom, left, right. Oh yeah, then I gotta fill at this edge. Okay, hold on. I can just I gotta do this for all 4. No. know what? There. Okay. Should I fillet those sides? I'll fillet those sides. So many sides to this thing. Now I'm picking boxes, no more boxes. And I see sorts my stuff now. And fixes my printers. Should we can do an exercise? You passed out in the middle of a video game last time. Even though I'm technically on vacation now, I think I still need sleep. Probably. Okay. That looks a little better. You know what? I'm going to print this and see if it actually fits. Oh! Almost forgot. This chain I'm going to delete. I'm going to make a piece here. Oops. I'm going to use my favorite screw of all time, the M2.5 by 6 millimeter screw. I think this will actually fit. Maybe like 3. Okay. So I'm going to make a offset plane here. I'm going to make a little case for this. I think that's actually good enough. So it's going to be a little flat plane. Maybe like like 3 millimeters thick. Right? And then it's going to have it's going to have holes. It's like all the way through. I'm going to make them less lazy holes because I don't want to be destroyed for doing this. For M2.5 by 6, I think it's just 3 millimeters. I don't know the tolerance from the back of my hand, but I think it's just 3 millimeters. Yeah. So this is going to be like a top cover that's going to go on top of the, well, obviously. It's gonna go on top of the solenoid just to lock it in place. And I think this is a slightly better way of doing it than using hot glue. Whoop. I forgot to do the bottom one. Just deselect this. Yeah, so hot glue is good, but you know what's better than hot glue? Screws. I'm gonna have another screws and tolerances workshop next semester. It's gonna be glorious. Okay. Nice little holder for the solenoid. Let me just make these into components and then clamp them in place. And then I just have to go ahead and print these out and test them to make sure they're okay. Well, this technically goes in external, but I'm going to make a new component. I'm just going to call it solenoid stuff. I'm going to put both the solenoid holder and solenoid cap inside solenoid stuff. I'm going to put solenoid stuff inside external. Okay. So then I'm going to go ahead and constrain some things. Joint some things. Join that. Just get out of here for a second. Of course, it's going to throw it down all the way down there. Okay. And then I'm going to joint this thing to not that. This. Chamber. There you go. What was I jointing? What is this? Oh. Joint. Okay. So that's the solenoid holder. It's literally going to be positioned on the outside of it. And then I just need to go ahead and copy this to the other side. So copy paste solenoid stuff. Move it. Rotate 180 degrees. Okay. And then joint it to battery holder. Hey, it's a pretty good fit. Okay. Hold on. It's upside down. I want to join it to the bottom instead. So the bottom there. Cool. So I think that'll do it for the solenoid holder. Now theoretically, right, if I get this exactly correct, then the solenoid will be dead center to the clamp thingy, the solenoid arm, and then it'll be able to attach itself in place very neatly. However, if I got any part of this tolerance incorrect, this is not going to work. So just no pressure, no pressure. I need to get like a CAD model of the solenoid. Hold on. Stream goals, text. I can finally check off redesigned solenoid support. Okay, that's 3 check marks. That's just 3 check marks in, what, 2 days? Okay. So, solenoid support is in. The holder thing is in. What's next? Wheels. Wheels. Okay, because this is going to be part of a rotational battery chamber, I'm going to have to find a way to attach some wheels to this. Now, luckily for me, I've already had a lot of experience with wheels in my Hyperloop project, so I'm literally just going to steal all the tolerances from that project and put it here. I remember when I spent 2 weeks on this during the winter. So the best 2 weeks of the time spent on stream. This thing. This is an amazing project. I still need to like redesign some of this stuff. Like instead of rubber bands on the wheels, I'm gonna make them out of TPU. But this was a fun project to CAD up. Okay. What I'm looking for is the ball bearing, so the tolerances on this part of it. Right. So I'm going to redesign this a little bit. If you remember the fork design for like the double wheels, this fork was interesting to CAD. Everything in here was put together by a press fit of this top cap. However, this is going to be very useless, I would say. And I want to put like a screw on top. I want to screw this top cap in. O-rings have some grooves to put O-rings in. What are O-rings? Google this. O-rings are like rubber clear O-rings. Interesting. It's a seal. I don't know. I've never worked with this before. O-rings are the backbone of all hydraulic gas. I mean, I've seen this before, but I don't know what they're called. All right. This is everything here is literally press fit together, which is awesome, but also kind of scary. Anyways. Okay, back to this. Okay. Cursed cat from East East, exactly. This is you don't do things professionally, you just do things for the memes. I mean, in that it turns into things that are done professionally. Also, lesson number 2, you do things out of spite. Spite wins. Welcome to the world of things that should work, but things that shouldn't work, but they do anyways. Oh, look at this tolerance. Oh, that's not gonna work. Huh. You know what? I'll put this in fine. Yeah, this offset is totally not gonna destroy all my hopes and dreams, right? Let's look on the other side. It's also offset. Okay. You do things for the memes, just put that on every poster you do in the future, and I will. Don't you worry, I definitely will. Okay, so now we have to like deal with the other two sides of this battery chamber: the bottom for the wheels and the top for the attachment to the drone. Oh god. Okay, how did I sketch this out? Or how did I imagine this? I get an O-ring from the harbor freight and put them on the wheels. Please, I will give bits to see this. Okay, I will. I have to do a lot of upgrades to the Hyperloop thing anyways, so... eventually we'll have to do so. Hey, Maggie. Hello there. Okay, wheel phase. I call this quote-unquote modular support. Okay, so what do I need to do? I need to steal the wheels from Hyperloop. Steal the wheels, steal the bearing sizes. Yeah. How did I organize this beautiful mess? Was it full side? Yes, inside here. Side wheel cap, support wheel. This is what I need. Okay, support wheel will go to a step file, and I will save this to my computer inside BVM. No. Inside a new folder I'm gonna call step files, just because I'm totally not gonna need this in the future. So these wheels are going on a bearing, which go onto this central axle here. Oh god. This thing is a hot mess. It's because each support wheel comes with a bearing model and also the support wheel itself. Oh god. Okay. Side wheel axle. And then I need the side wheel cap. Yeah, using these three pieces I can rule the world. Haha! I still remember I used to use 3D printed spacers because I didn't want to use like the metal ones. Hey, I mean, I've got a bunch of 3D print parts, I might as well use it, right? I mean, it worked. I guess. I'm telling you, like 90% of my final ECE project is going to be CAD, and not actually ECE stuff. I have to do senior project next semester, I think. Maybe. Okay. Wheels. Ah, my goodness. You're gonna pick your final project. No, my final project is this. Thank you, Obese Scamurai, for the follow. Welcome along. Welcome on board. Okay, let's see how many versions I can rank this up to. Okay, so we have the battery chamber, we have the combined arms, we have the solenoid thingies, we have the back thing for PCB component. I still have to design the PCB for this. I have this thing for the wires. I need stuff for the bottom. It's gonna give me a massive headache. Okay, so let me just Microsoft Paint what I'm gonna do, because I think that's gonna be a better way of drawing out what I want. And I'm pretty sure that my tablet is not. Okay, I'm gonna draw this with mouse. Okay, this is gonna make 0 sense. So let's say this is the battery chamber, right? Battery stuff. There's gonna be a wheel down here that kind of looks like this. Let's draw that again. So this is gonna be the bearing, and this thing will turn, right? And then attached to the bottom is going to be a long pole that is attached to maybe like inwards, 2 more wheels at the bottom. And there's going to be basically 2 of these inside the model. So you're going to have rotation in the XY direction, and then rotation in the, this is YZ direction. Right. So then it's basically like those office wheels where you can turn in any direction possible. And then everything is guided by a center beam that attaches to a central motor, which turns everything, like literally everything, in the XZ direction again, so that the differential between the larger motor and the smaller piece turning will even out. Does that make kind of make sense? Also, I'm going to go ahead and have this copied and pasted here on the front too. So the front's gonna have a wheel thingy, the back's gonna have a wheel thingy, the whole world's gonna love it. Right? And then it's all gonna be rested on it's all gonna be rested on 2 circular platforms. In which the battery is going to be inserted through here. Right? Art. Hey, this is mouse art. The best mouse art you've ever seen. Is my camera in focus? I feel like it is. Maybe it's just my glasses. It is my glasses. It's too late in the day for this. Anyways, that's my idea. Implementation? Questionable. But hey, you gotta start somewhere, right? So this wheel structure is only going to be for the rotating battery chamber. For the drone, this is not going to be here. And instead, there's going to be some sort of structure up here, which attaches to the drone itself. And the bottom's going to be missing. So this same chamber design can be used for both the storage unit and the drone. I am very slow right now. It's too late in the night for this. Picasso would be proud. I can also draw the solenoid thingy. There. Solenoid. Slow. Okay. So, I need 2 sets of wheels, pretty much. One set is going to be on the front, and one set's going to be on the back. Be real nice if I could use this piece right here to do the wheels, but unfortunately I can't because some dude decided it would be a great idea to make that hollow, but it's okay. No hard feelings. Okay, first thing, counter position. First things first. First things first, draw a rectangle. That is a nice size. Sure. Second thing. Find the midpoint between these two areas, because apparently they're the most distinctive features in the entire chamber, which is those. Whoop. Okay. I forgot to make an offset plane for this. Frick. Okay, this is why you make offset planes. So that you don't run into issues later on. Okay. Wheel stuff. Real wheel stuff. Okay, I'm going to be smart about this and only project these 4 points. And then I'm going to make a point in the center of those 4 points. Oh, gotta love Fusion telling you what's wrong, what's what. Save my work. Yes, thank you. We're on version 28 of this battery shell thing. I have poured hours into this. Unaccountable hours. Okay, so what would be the best way to attach a giant wheel structure to this platform? Oh, I know. How about making this like a 5-pointed thing? We can use 5 screws. Hot glue. So many hours for it to be fragile. Exactly. Exactly. Don't hit the nail on the head. Or you hit the battery on the head. Oh, you know what? There's a reason why I had... There's a reason why I had this sketch be on... I bamboozled myself. Okay. So I'm going to make these M3 screws. 1, 2, 3, 4, 5. Group 3.0. 5 right-hand model. How deep is this thing? Can I make it 5? No, I cannot make it 5. Okay. Big bad screws incoming. So now I can make a offset plane. My goodness. Go to my sketch. Find this sketch. Project these things. I realize that I'll need to reprint one of these battery chambers in order to get this correct, but I don't care. I also need to color those pieces. I realize that color makes a huge difference in what you make. Makes it's just a slightly more tolerable, you know. It has to be 7.5 for a 20. Center rectangle. .5. That was not right. I don't know how I used to be able to do like long haul catting streams back then. This is hard. I'm losing my focus after just 1 hour. Maybe I'm getting soft. Okay. Big boy piece right here. Okay, so if I need to make this screw a M3 countersunk, that's gonna be M3/6, and it's gonna be 2 millimeters deep. 5. I have to extrude by 5. Okay, and then on here. Go ahead and project these points. Okay, finish the sketch, and then make my holes. It's gonna be countersunk, simple, flat. Hey, it saved my holes. 3. No, this is gonna be 5 deep. 6 to 3.5. Nice. Okay. And then I'm gonna go ahead and fillet the corners. Oh, this thing is never falling off. So many screws on this bad boy. This is looking like that one level in Wii Play, or Wii Sports. Like one marble level. No, it was like the Wii Fit balance board. It was like one of the first levels in that game where you had to like tilt to put the marbles inside the holes. And there was like one that looked exactly like this. That one level. What was it called? It was Wii Fit. Wii Fit marble game. You gotta find this. Marble Madness. Oh hey, Sensation Black. I have no idea what that says. I can Google Translate it though. Yeah, it was the Wii Fit Marble Madness game. Got a hit of nostalgia there. Okay. It says, what are you doing? I am doing some CADing for projects. This is my battery vending machine thing, and I'm just making the wheels for it right now. You think this is good enough for wheels? Probably. Maybe. Well, I still need a way to attach to the center. Well, that center hole is probably not going to work out so well. All right, real fast here. Yeah, that center hole's not gonna work. Yeah. Bam. Same for this one. Gonna make one in the center. Okay, and then the center is gonna be the rod that goes into the bearing. Oh, this is gonna be a fun print. My printer's gonna hate me. Okay, so I'm gonna find the center of this thing. I'm gonna attempt to find the center of this thing by just projecting it. My ears. Oh, thank you for the follow Make Your Life TV. Glad to have you here. At this point, I'm like very used to the ringing of my ears. Every time that happens. Is my Raspberry Pi still running? It is. Huh. Interesting. I know Raspberry Pis can run for a long time. I have my setup over there in the corner, in case any of my teammates want to go ahead and try it out. How's it faring? Pretty well. Not too hot. It's over there crunching some numbers for an endurance test. Hey, Chris, this is the channel looking Saturday. Oh, is this Slack? Oh, I knew this was Slack before I even read Slack, but hey, Slack, good to have you here. Yeah, you guys should go ahead and check out Make Your Life TV. Lol, port ears. Hey, Outlaw. What's on the Pi? It'll just derate. We're doing an endurance test of data measurements. There's no shadow command here, unfortunately. I gotta like change that really. The only bot I have on my channel is the one I made a long time ago, using a Python script. The Pi is currently just running a desktop server. Like, I have team members going on it and coding. I can show you. So, luckily, I'm not doing this by myself. And I have team members that are actually coding this. I think what's going on is RPi client. Yeah, so right now, RPi client is running a script to retrieve the battery data from the station. It's hooked up to an Arduino Mega and hooked up onto the battery array I showed last time. And if you run this script, I think this is connected to a server right now. No, it's not. Let me see what happens. List the next round of range. Oh, great. Well, theoretically, before this happened, it should print out the battery voltage. I might have to, like, go in here and take a look at what's going on. Huh. And just do a little bit of, the lag is, fun to deal with on the Raspberry Pi. Okay, yeah. Battery voltage, see a link. Oh, that'd be cool. Yeah, I mean, this is pretty much it. You get a list of numbers from the Arduino, and then apparently my teammates are organizing it in some sort of database. It's nothing heavy. I don't know what's going on down here though. Yeah, no clue. But that's pretty much it. My Raspberry Pi is like lagging real hard right now, so I think I'm gonna go ahead and push this to GitHub and then call it for now. Okay, I gotta do a sudo shutdown now. Talking to laptop batteries of the ESP8266. Interesting. Interesting. An open laptop battery packs that are powering my ESP. I will have to take a look at this later then. Thank you, Kandarsa, for the resource. Appreciate it. Now I can just close this and unplug my Raspberry Pi. It's been running for like a couple hours now, so. Don't you have a PR to... I do have a PR to do, Kandarsa. I've just been prioritizing with an average amount of intelligence. I've got to finish this first before I do that. I'm sorry, Kandarsa. I will get to it, though, eventually. Anyways, okay, time to steal some data from this project here. So, the diameter of the cap of this thing is, why is it not in millimeters? The diameter of this thing is 8.4 millimeters. Right. I remember the time when I was like intricately changing this. Like literally this cylinder had to be 8.04 millimeters or else it wouldn't work for some reason. 8.04 millimeters. It was a crazy amount of precision that this thing had. Alright. I'm just gonna use 15 millimeters. That's a good enough length. Maybe 20. Right, so the first one's gonna rotate in the XY direction to compensate for the error in the bigger motor that's connecting to the back of this. Speaking of which, I should probably like put some screws in the back just so that it has something to connect onto. Maybe like over here. That'd probably be a good idea. Okay. Yeah, this sticks out the bottom. Oh my goodness, what'd I do? Plastic. Oh. Okay. So, this is gonna be it. And then I just import one of those wheel bearing thingamajigs into here. Load support wheel. This thing. I don't feel like catting this again. I'm just gonna reuse it from Hyperloop. Okay. Doink. Oh great, it's large. The origin is also in a questionable location. Okay. Wait, no. No, hold on. Wait, no. Okay, set pivot to a reasonable location. Check mark. Alright. So the bearings that I'm using have like weirdly specific tolerances. So yeah, I'm just gonna drag this here and press OK. And so I'm pretty sure this is gonna be a support wheel. Okay. It is. Break the link. What? What? Break link. Okay. The bearing itself and the 3D print on top of it, this is like an exact tolerance for some reason. Which is weird. Which I'm fine with. That piece I'm gonna have to wheel holder. I'm gonna turn into a component first. And I'm gonna make a new component just for this stuff called modular. Okay. So I'm gonna joint this piece and this piece together. Put it like almost all the way up here. Like this piece doesn't matter whether it moves up or down because it does matter whether it moves up or down. Just kidding. Okay, I'm gonna shove it as far in as it'll go. It's like 19 millimeters before it like bottoms out. Sure. Because that fillet is actually pretty important. Wait, I thought this was... Hold on. I thought this was a rigid body. Okay, and then I'm going to put up 19. Oh, yeah, okay, so theoretically this will turn. And then I need to, like, fix that. Oh, there's so much stuff here. So this extrusion, I need to, like, push it back. Like 15 maybe. Maybe. Yeah, okay. That'll probably do it, to be honest. And then I need to make a cap that I'll screw onto the bottom to prevent it from going down. So it'll have some springs. Bearings need a groove around it for the O-ring. O-ring can get a diameter of 2 millimeters. Or I can just press fit it. Because the bearing will directly go into the 3D print, which will go onto a direct... which will directly go onto a TPU ring of around 2 millimeters, which will be the O-ring. I see. Where you put the rubber? Yeah. I get it. Make 2 or 3 grooves as a half circle 2 millimeters. Hold on. And you see what this looks like on an actual bearing. Because I can't visualize what you're telling me right now. Alright, I'll see you, Bellum. Good night. I can visualize what you're telling me right now. Okay, Alright, so I'm gonna need to edit the support wheel sketch, I think. So this thing. I'm gonna hide it. And then make 2 or 3 grooves that's a half circle 2 millimeters. Can I just like extrude this back by 2 millimeters then? Would that work too? I mean, depending if I'm putting it on the outside or the inside, right? Because I think for these ones, I have to hammer them in really hard. Look at Link. Do they go on the outside of the wheel then? It's in place of the rubber band. Oh, so on the outside of the wheel. I see. So like on the outside here. Outside. Okay. 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 How the heck do I do that? Alright. So what's the diameter of this thing? Or the circumference? Diameter is 35.56 millimeters, which means 35.56 millimeters times pi is 111.715, which is the circumference. So I construct a tangent plane on this wheel, and on the tangent plane, I project this object, and then I make a rectangle from the bottom of this all the way to the top with 111.715. Then that'll basically wrap around the entire thing when I do an emboss. And then all I gotta do to make the things that can also show me in this picture, just agree over to it if you want friction. Yes. So then I'll have 2 millimeters, right? That's like half the wheel. Okay. 2 millimeters thickness O-ring. I need to buy that too. And I just do an emboss. Do the faces. And then I'll have a. What's the depth? Do you know? Is it just 1 millimeter? Half millimeter? Half circle? Oh right, so like that cuts it. That cuts directly into my wheel, which is fine. I think I think I need to make it slightly longer. Hold on. Make this like 11.8 or something. Why does it emboss like that? What is this? Why is this here? Can I like? Okay. Pretend that was never there. And then based on this, I should be able to put an O-ring there, right? I would make a 2 millimeters donut on the wheel and subtract that, but that's an SCAT thing. I think I'm just gonna go ahead and... I don't know why I didn't emboss it correctly. Maybe I need like... Let's 7.5. Just add a little piece on the back here. Why did it move? I don't know why this remained. Self-intersecting body. Of course it did. This is not. I was picturing a round. Does not do a subtraction. A 2mm ring would be easy to make. I mean, the way I subtract it, if it's usually in a circular shape, is using a tangent plane of an emboss. Unless there's a different way to do it that I'm not aware of. Huh. Skip it then. I mean, I was just gonna do a TPU ring. Let me see if there's O-rings on Amazon. I can just pick up. And that's what I do. That's the engineering way. I'm just gonna pick up some O-rings. I wonder if they have it in my size. What is this size thing? 35.56 millimeters. Do they even have O-rings that big? The Harbor Freight kit is cheap. Let me look at Harbor Freight then. O-rings and grommets, Harbor Freight tools. That's pretty cheap. Amazon kit is cheap too. I'm getting the feeling that these are pretty cheap. I'll do Amazon because it's easier to reimburse slightly. All right. You know what? I'm gonna do the wheels tomorrow, and then tomorrow's Wednesday. I'll do the wheels on Wednesday, and then I'll do the rest of it on Thursday, and then we'll be ready for Friday. And that's gonna be the end of this until fall semester. I'm gonna end the stream net now though, because I can't work on this for more than 2 hours without going insane. So, thank you guys so much for watching today. Notice I'm just going to steal that link real quick. Yep. So, thank you guys so much for watching today. I'm going to raid Maker Deck because there's no one else to raid right now. But, again, we're raiding Maker Deck. Unless you guys got a better option. If you guys have someone you want to raid, then let me know. I should be like streaming it at a normal time again. Now that like all that chaos from the last 2 weeks has been over, but sorry for the last 2 weeks again. Oh, I currently show of my new camo maker deck. Alright, to maker deck we go then. Something special. That's fun. Maybe I'll do some belty stuff on maker deck someday. But as of now, thank you so much for watching, guys. I'm going to head off now, so have a great rest of your night, and I will see you later. Bye-bye!